Understanding the impacts of climate change on weather patterns. Climate change significantly alters weather patterns, resulting in severe environmental consequences. As global temperatures rise, various phenomena such as intensified precipitation, prolonged droughts, and rising sea levels emerge, reshaping our climate landscape. This summary explores these critical impacts and their implications for the environment and society. Intensified precipitation and storms. Warmer air leads to more intense rainfall. As the atmosphere warms, it can hold approximately 7% more water vapor for every degree Celsius of temperature increase. This change results in increased rainfall events. Regions may experience more frequent and intense rainfall, leading to flooding and infrastructure challenges. Stronger hurricanes. Warmer ocean waters fuel hurricanes, making them more destructive. These storms can produce stronger winds and heavier rain, exacerbating coastal damage and increasing the risk to life and property. The combination of these factors indicates a shift in weather extremes, highlighting the need for improved preparedness and infrastructure resilience. Worsening droughts and heat waves. Climate change contributes to prolonged droughts and extreme heat. As temperatures rise, the rate of evaporation increases, resulting in drier soil and water bodies. Increased evaporation leads to faster drying of soils and lakes, which can severely impact agriculture and drinking water supplies. Severe and long-lasting droughts become more frequent and widespread, affecting food security and local ecosystems. Prolonged heat waves. Higher temperatures can create heat domes where stable atmospheric conditions trap heat in specific areas, leading to prolonged periods of extreme heat. These conditions pose significant challenges for agriculture, water management, and public health, necessitating adaptive strategies to mitigate their effects. Disrupted atmospheric circulation. Changes in temperature gradients disrupt major wind patterns. As the climate warms, the dynamics of the atmosphere shift, resulting in altered jet streams. The jet streams that influence weather patterns can become stuck, leading to prolonged weather conditions such as extended heat waves or persistent rainfall. Stagnant weather systems. This disruption can cause certain regions to experience unusual weather patterns, such as prolonged flooding in one area while another faces drought. Understanding these changes is crucial for predicting weather patterns and preparing for the associated risks. Rising sea levels and storm surges. Melting ice and warmer oceans contribute to rising sea levels. The consequences of these changes are profound. Increased coastal flooding. Higher sea levels lead to more frequent and severe coastal flooding, especially during storm surges associated with hurricanes and other severe weather events. Erosion of coastal areas. As sea levels rise, coastal erosion accelerates, threatening infrastructure, habitats, and communities. Impact on coastal ecosystems. Rising waters can inundate critical habitats such as wetlands and estuaries, leading to loss of biodiversity and disruption of local ecosystems. Addressing these challenges requires comprehensive coastal management strategies and investment in resilient infrastructure. Feedback loops and climate acceleration. Feedback loops exacerbate climate change impacts. One significant feedback mechanism is the albedo effect. Reduction of reflective ice. As ice melts, the reflective white surface is replaced by dark ocean water, which absorbs more heat. This process accelerates warming and further disrupts climate patterns. Amplified warming. The more ice that melts, the more heat is absorbed, creating a cycle that can lead to even more severe climate impacts. Recognizing these feedback loops is essential for understanding the long-term trajectory of climate change and the urgency of mitigation efforts. The dry gets drier, wet gets wetter pattern. Climate change leads to a dichotomy in weather extremes. The overall trend can be summarized as a dry gets drier, wet gets wetter pattern, which manifests in increased flooding in some areas. Regions that are already prone to heavy rainfall may experience even more intense flooding, leading to infrastructure damage and displacement of communities. Severe drought in others. Conversely, areas that are typically dry may face exacerbated drought conditions, threatening agriculture and water availability. This duality underscores the need for targeted responses that address the unique challenges faced by different regions. Conclusion. In summary, climate change is reshaping weather patterns globally, leading to intensified precipitation, prolonged droughts, disrupted atmospheric circulation, and rising sea levels. The resulting impacts create a complex landscape of challenges that require proactive strategies for adaptation and mitigation. Understanding these changes is essential for developing effective policies and practices to safeguard communities and ecosystems in a rapidly changing climate. As we move forward, it is critical to prioritize resilience and sustainability to address these urgent issues.